In this lecture, we will discuss about problem based on gamma distribution. So here we write problems based on gamma distribution. So first we revise the PDF of gamma distribution. So the PDF of gamma distribution fx is equal to lambda raised to the power alpha, lambda raised to the power alpha, x raised to the power alpha minus 1, e raised to the power minus lambda x upon gamma alpha. ये symbol है, that is the gamma alpha, where x greater than 0 and second 0 otherwise. So here we have two parameter alpha or lambda, both are positive. Or the value of gamma alpha. So this we can define by using the gamma function. So this gamma alpha we can write down as e raised to the power minus x, x raised to the power alpha minus 1 into dx. आपको ध्यान रखना है कि जो गामा फंक्शन की डेफिनेशन है वहीं से हम गामा अल्फा को सॉल्व करते हैं. तो गामा अल्फा दैट मीन्स दिस इज अवर अल्फा, सो हियर अल्फा वी टेक एज दिस अल्फा. नाउ वी राइट डाउन द CDF. So the CDF of gamma distribution, CDF of gamma distribution. So we write down the CDF, we denote it as capital Fx. Capital Fx is equal to integration 0 to x, and we say that Fu into du. So Fu into du. So this we can write down as lambda raised to the power alpha upon gamma alpha, because this is constant, and we take integration 0 to x, x raised to the power alpha minus 1, e raised to the power minus alpha x. So alpha x we denoted as generally in u, because we take the function as fu. So we write down this as u raised to the power alpha minus 1 or e raised to the power minus lambda u into du. So we can integrate this. Now, after writing the PDF and CDF of gamma distribution, we remember one important node where we use this distribution. What are the application of this distribution? So basically the gamma distribution, so we write down as gamma distribution is generally used to solve rainfall analysis. Solve rainfall analysis, which may be daily, weekly, monthly, or annually. So we basically use the gamma distribution for rainfall analysis. So on the basis of this rainfall analysis, we take one problem based on this rainfall analysis. So we start the question, very important question based on a rainfall analysis. So question is during the month 1, during the month 1, the mean and standard deviation the mean and standard deviation of monthly rainfall of monthly rainfall are 0.5, 0.5 and 0.3535 centimeter respectively. Assuming monthly rainfall data can we approximate by gamma distribution? Approximate by gamma distribution. So first part, obtain the probability of receiving more than 1 centimeter rain, receiving more than 1 centimeter rain during month 1. During month 1. Second part, during month 2, the mean and standard deviation of monthly rainfall, the mean and standard deviation of monthly rainfall are 1 and 0.5, 1 and 0.5 respectively. So here we have a two part in this also. So obtain the probability of receiving, obtain the probability of receiving more than 1 centimeter rain, 1 centimeter rain during month 2, during month 2. Second, obtain the probability of receiving more than 1 centimeter rain, 1 centimeter rain during the 2-month period, during the 2-month period, assuming that rainfall assuming that the rainfall during the month 2 during the month 2 are independent. So this is our question. So we will solve this question in two parts. So first we obtain for month 1, then we obtain for month 2. So previously we solved for month 1, then we solve for month 2. And we obtain the 2-month periods. So we do the solution of this question. So now we see that the mean and standard deviation of monthly rainfall are zero point 0.5 and 0.3535 respectively. So point we write down as given that. So here we solve this question in 2 months. Okay. So first month we write down as x1, second month we write down as x2. So here we take as month 1 or month 2. So first we solve this problem for month 1. So now given that the mean mu is equal to zero point 0.5 and a standard deviation sigma is equal to 0.3535. So mean and standard deviation is given. So now we calculate the parameters. Okay. So when mean and standard deviation of gamma distribution is given, so we calculate the parameter. So to obtain the parameters, here to obtain the parameters. So how many parameters this distribution have? So this distribution having two parameters. One is lambda or second is alpha. So we know that to obtain parameters lambda and alpha. So now we have a mean mu or expectation of x. This is alpha upon lambda. So this is our formula we have proved in previous video. So mu is equal to alpha upon lambda. So we put the value of mean mu is 0.5, 0.5 equal to alpha upon lambda. Now, similarly, in parallel, we write down the value of standard deviation. Standard deviation, that is sigma. So sigma is equal to, so we write down the sigma. Sigma is equal to root alpha upon lambda. So we have already proved this. So we put the value of sigma 0.3535. This equal to root alpha upon lambda. Root alpha upon lambda. Now, when we simplify this, so here we calculate the value of lambda. So what is the value of lambda? The value of lambda is alpha upon zero point 0.5. So alpha upon zero point 0.5. Now this value of lambda we can put into the this equation, second equation. So now we can write down at 0.3535 is equal to root alpha upon lambda. So what is the value of lambda? Value of lambda is alpha upon zero point 0.5. So alpha upon zero point 0.5. So this we can write down as, so 0.3535, this equal to root alpha into zero point 0.5 upon alpha. So this root alpha to alpha cancelled by root alpha times. So now we can write down this as, so this can be written as 0.3535 is equal to zero point 0.5 upon root alpha. So what is the value of root alpha? So the value of root alpha is equal to 0 0.5 upon 0.3535. So 0.3535. So this value, when we divide this, is approximately 1.414. 1.414 when we divide zero point 0.5 by 0.3535. So when we do the square both side, so this alpha gives us approximately 2. Okay, because the square root of 2 is approximately 1.414. So this is the value of first parameter alpha. Now when we know one value, so we can obtain the second value. So we can obtain second value. So here we can put the value of alpha. So lambda is equal to 2 upon zero point 0.5. So this gives us 4. So lambda is equal to 4, alpha equal to 2. So when we obtained these two parameters, because these are the necessary parameter for gamma distribution, so we can write down the probability density function. So now the PDF of gamma distribution. So PDF of gamma distribution. So we write down as fx is equal to lambda raised to the power alpha x raised to the power alpha minus 1 and e raised to the power minus lambda x upon gamma alpha where x greater than 0 and 0 otherwise. So here we put the values of parameters. So lambda value is 4, alpha value is 2, 4 raised to the power 2 into x raised to the power 2 minus 1, x raised to the power 2 minus 1 or e raised to the power minus 4x upon gamma alpha. Alpha means gamma 2. Gamma 2. So x greater than 0 and 0 otherwise. So we already know that the value of gamma 1 is 1 and gamma 2 is also 1. So the gamma 2 value is 1. So we can write down this as 4 square is 16. 16x e raised to the power minus 4x. So this is our PDF when x greater than 0 and 0 otherwise. Okay, otherwise means x less than or equal to 0. So function value is 0. So this is fx. So after writing the probability density function fx, now we calculate the rainfall. So now uh, here, this is our first part. Obtain the probability of receiving more than 1 centimeter rain. More than 1 centimeter. So means x, our random variable x is greater than 1. So more than 1 centimeter rain. So the required probability, so we write down as the required probability P more than 1 centimeter rain. So x greater than 1. So x greater than 1, this can be written as 1 minus probability of x less than equal to 1. Okay, so this is a property. So this we can calculate as 1 minus probability x less than equal to 1. So less than equal to 1 means x is positive, so 0 to 1. So integration limit will be 0 to 1 less than equal to 1. From 0 to 1 and a function fx into dx. Okay, so fx into dx, so we have a fx is 0 to 1, fx is 16 x e raised to the power minus 4x into dx. So now we integrate this. So 1 minus 16 we take outside from the integration. 0 to 1 x e raised to the power minus 4x into dx. So again we use the islets. So this is for differentiation. This we consider for the integration. So here we use this as u and v. So we already know the formula when we integrating product function uv into dx. So we say that u into v1, v1 means one time integration minus u dash one time differentiation of u into v2, two time integration of v plus u double dash two time differentiation of u, three time integration of v and so on. So we write down 1 minus 16. Now first function u we write as it is x integration of e raised to the power minus 4x. So e raised to the power minus 4x का integration क्या हो जाएगा e raised to the power minus 4x upon minus 4 minus x का डिफरेंशिएशन क्या हो जाएगा 1. x का डिफरेंशिएशन 1 हो गया. अब इसका दो बार इंटीग्रेशन करना है. एक बार हमने कर दिया, दोबारा इंटीग्रेशन करेंगे तो सेकंड टाइम इंटीग्रेशन विल बी माइनस 4x अपॉन माइनस 4 हो रहेगा. तो माइनस 4 ये है, माइनस 4 हो रहेगा तो माइनस माइनस प्लस 16. नाउ द डिफरेंशिएशन फर्स्ट टाइम इज कांस्टेंट, तो सेकंड टाइम डिफरेंशिएशन क्या हो जाएगा 0 हो जाएगा. 0 हो जाएगा तो वी डू नॉट need to write the next term. So we stop the formula. So then we put the limits. So first we apply the upper limit, then we apply the lower limit. So this is 1 minus 16 into, when we put x equal to 1, so 1 into e raised to the power minus 4 upon minus 4 or minus e raised to the power minus 4 upon 16 and lower limit, so minus minus plus on the basis of this. So x equal to 0 means gives us 0, or this minus minus is plus. So e raised to the power 0 is 1, e raised to the power 0 is 1 upon 16. So 1 upon 16. Now we write down this as 1 minus सो 1 माइनस 16, और यहाँ पे ये क्या है, e रेज टू द पावर -4 अपॉन -4 है, यहाँ -16 है, तो 16 एलसीएम आ जाएगा दोनों का। तो 16 एलसीएम आएगा, 4 4 जा 16, तो ये कितना हो जाएगा, तो -4 और -1, तो -5 हो जाएगा। तो दिस इज -5 अपॉन 16 e रेज टू द पावर -4 और +1 अपॉन 16। ओके, सो नाउ वी राइट डाउन दिस एज 1 माइनस 16, इनसाइड ले जाएंगे ब्रैकेट के, तो 16 से 16 कट जाएगा दोनों, तो ये हो जाएगा 1 -5 e रेज टू द पावर -4, 5 e raised to the power -4. So we can calculate this. So approximately the value of this will be 0.092. So this is our first part. We have done the first part. So this is our first part. Now we move to the during the month 2. So we have done this first part, that means x1. We shall move for the second part, that during the month 2. और मंथ 2 के लिए भी सेपरेट वैल्यू दे रखी है, स्टैंड मीन अलग दे रखा है, स्टैंडर्ड डेविएशन अलग दे रखा है, तो वी स्टार्ट ए फ्रेश। So then we start the press. That means we do the second part. So here we solve the second part. So given mean mu, mu is equal to 1 centimeter, 1, and as the standard deviation, which is sigma, sigma is equal to zero point 0.5. So now we calculate parameters lambda and alpha. So same thing we will use here also. So what is the formula for mean? Mean mu, mu is equal to alpha upon lambda, and standard deviation sigma, sigma equal to रूट अल्फा अपॉन लैम्डा। तो रूट अल्फा, आपको रूट में और उसमें डिफरेंशिएशन पता होना चाहिए, ये मैं रूट लगा रहा हूँ इस तरीके से, और गामा का सिंबल है ये गामा, ये सिंबल है गामा के लिए, और ये किसके लिए है, ये रूट के लिए। ओके, सो यू डिफरेंशिएट। सो हियर वी राइट डाउन द वैल्यू ऑफ mu and sigma. So mu value is 1, 1 is equal to alpha upon lambda, and this value 0.5 is equal to root alpha upon lambda. So root alpha, so here this gives us alpha equal to lambda, so alpha equal to lambda. So now we shall to that, so that means this can be written as uh, root alpha upon lambda. So we write down that 0.5, 0.5 is equal to 0.5 is equal to रूट अल्फा अपॉन लेमडा इक्वल टू भी अल्फा पुट कर देंगे, तो लेमडा इक्वल टू अल्फा, सो यहाँ से हमें क्या ऑब्टेंड होगा, so this equal to 0.5 equal to 1 upon root alpha. So we obtained 0.5 is equal to 1 upon root alpha. What is the value of root alpha? The value of root alpha is 1 upon zero point 0.5. So 1 upon zero point 0.5 is 2. So when we do the square, both sides, so 2 to the 4. So alpha is equal to 4. Alpha equal to 4. So when we have alpha equal to lambda, so lambda is also equal to 4. So both the parameter having the value 4, 4. Alpha equal to 4 or lambda equal to 4. So when we obtain these two parameters, now we write down the PDF. So the PDF of gamma distribution, the PDF of gamma distribution, so that fx is equal to lambda raised to the power alpha x raised to the power alpha minus 1 e raised to the power minus lambda x upon gamma alpha, here x greater than 0 and 0 otherwise. So we put the value of lambda and alpha in this. So we see that 4 raised to the power 4, x raised to the power 4 minus 1, e raised to the power minus 4x upon gamma 4, gamma 4. So here x is greater than 0 and 0 otherwise. So we simplify this. So this fx is equal to 4 raised to the power 4 So this will be the 256, and here is x cube e raised to the power minus 4x. So x greater than 0. Or gamma 4. What is the value of gamma 4? So the value of gamma 4 is equal to factorial 3, means 6. So here we put it as 6. So now 0 otherwise. So we know that the relation between gamma and factorial gamma n plus 1 is equal to factorial n. So now we calculate the required probability. So for first part, obtain the probability receiving more than 1 centimeter during the month 2. So same during the month 2, more than 1 centimeter rain. So more than 1 centimeter rain. So we again write down uh, more than 1 centimeter rain. So more than 1 centimeter rain. The probability of random variable x greater than 1 is equal to 1 minus probability of x less than equal to 1. So 1 minus, so this also can be written as 0 to 1 or fx into dx. So this equal to 1 minus integration 0 to 1 और fx क्या है हमारा 256 upon 6 x cube e raised to the power minus 4x into dx. So now we do the integration of this. So same formula we will use here also. So 1 minus 256 upon 6 is constant. We take outside from the integration. X cube e raised to the power minus 4x into dx. So this x we consider for differentiation. This e raised to the power minus 4x we consider for integration. और differentiation वाले को क्या यूज करते हैं u और इसको क्या करते हैं v. v means integration और du means differentiation. So now we are going to apply the formula. So this u we write remains same integration of v. So e raised to the power minus 4x upon minus 4 one time integration minus differentiation of u the x cube का differentiation 3x square and two time integration of v e raised to the power minus 4x minus 4 or minus 4 is 16 plus 16 plus differentiation two time differentiation of this so one time differentiation of this two time differentiation is 6x into three time integration 64 because we have x term also so we again write the next term so then again differentiation what is the differentiation of 6x this is constant 6 and 4 time integration of this 4 time integration the minus minus plus 64 4 ja 256 and this is our constant so next term will be 0 so we stop the formula. So now we put the limits. So this we can write as 1 minus 256 upon 6 into when we put x equal to 1. So 1 q is 1, 1 into e raised to the power minus 4 upon minus 4 minus 3 e raised to the power minus 4 upon 16 plus 6 e raised to the power minus 4 upon minus 64 or minus 6 into e raised to the power minus 4 upon 256 or lower limit. Lower limit, so minus that minus minus plus 0 when we put x equal to 0. So this gives us 0, again 0, minus this minus plus or this minus minus plus. So e raised to the power 0 is 1, so 6 upon 256. Okay, so e raised to the power 0 is 1. So we write down as 6 upon 56. So now we simplify this. So 1 minus 256 upon 6. So here we take as a 256 LCM. So in this term we take as 256 as LCM. So 64. So this can be written as minus 64 e raised to the power minus 4 or minus 16 16 ja 256 so 16 3 ja 48 48 e raised to the power minus 4 64 4 ja 4 6 ja 24 minus का 24 e raised to the power minus 4 and minus 6 e raised to the power minus 4 or plus 6 upon 256. So here we write down this as 1 minus 1 upon 6. 1 upon 6. So this will be 64. 64. So 4, 8, 12. 12 for 16. 16 or 6. 22. Or 6 for 10. 10 or to 12. 12 or to 40. 142 e raised to the power minus 4. So all are negative. All are negative. So we add all the terms and plus 6. Okay, so 256 to 256 cancelled. Now we write down this as 1 minus. So when we divide by 6, so 1 minus 6 to the, so this can be 142 upon 6 e raised to the power minus 4. So the answer will be approximately 0.4335. So 0.4335. So this is our answer. So we have done the first part. We have done the first part. Now we shall move to the second part. What is our second part? So the second part is obtain the probability of receiving more than 1 centimeter rain during 2 months period. During 2 month period. We have separately solved for month 1 and month 2. Now we solve for the 2 month period, assuming that rainfall of during month 2 are independent. So now we solve. So we are going to solve the second part. So second part, the probability of receiving rainfall more than 1 centimeter rain more than 1 centimeter rain during 2 month period. So the value, both are independent. So the value lambda 1 is equal to lambda 2. So lambda 1 because all are independent. So we can say that, and the rainfall during the 2 months are independent. So the distribution we write down as x1 plus x2. So x1 we consider for month 1, x2 for month 2. So we'll have the parameters alpha and lambda. So then the value of alpha will be alpha 1 plus alpha 2. So this will be 2 plus 4 is equal to 6, and lambda. So lambda be the second parameter that is independent, which we consider as 4. So now, so we make the PDF. So how to make the PDF? So we take x1 plus x2. So we merge the PDF of both. So we write down as lambda raised to the power alpha, x raised to the power alpha minus 1, e raised to the power upon gamma alpha. So here x greater than 0, second is 0 otherwise. So we take as this. So now we write down this as lambda, which is 4. So lambda is equal to lambda 2 because the rainfall is independent. So that's why we take. So 4 raised to the power 6, 4 raised to the power 6 into x raised to the power 6 minus 1 is 5. So e raised to the power minus 4x upon gamma 6. So gamma 6, here x greater than 0. So what is the value of gamma 6? The value of gamma 6 is factorial 5. So what is the value of factorial 5? Which is 120. So which is 120? So we again write down this as 4 raised to the power 6 upon 120 x raised to the power 5 e raised to the power minus 4x x greater than 0. So now again we calculate the more than 1 centimeter rain. So our question is the assuming the rainfall are independent, so we receiving more than 1 centimeter rain also here. So more than 1 centimeter rain. So we are going to solve for more than 1 centimeter rain. So more than 1 centimeter rain. So we write down probability x1 plus x2 which is greater than 1. So that equal to 1 minus probability of x1 plus x2 less than equal to 1. So this equal to 1 minus, again we take the integration 0 to 1 fx x1 plus x2. So we function we write down it. This one means fx into dx. So this will be 0 to 1. So we write down as 4 raised to the power 6 upon 120 x raised to the power 5 e raised to the power minus 4x into dx. So again we use the same formula to solve this integration. So you can solve the integration and the value we write down as 4 raised to the power 6 upon 120 0 to 1 x raised to the power 5 e raised to the power minus 4x into dx. So try to solve this. The answer will be 0.785. So other problems we will solve in next video.